Alright, hello Ag Construction class. This is the last video in this first half of the electricity series, and in this video we're going to talk about Ohm's law. So in the last video we talked about how to calculate volts, amps, and wattage, and we talked about that West Virginia formula, which was watts equals volts times amps. Ohm's law is very similar in how you work it and how you find it, but it's got a few different variables in play there. So to start, Ohm's law is the relationship between electrical current, electrical force, and resistance. So back to the wattage, volts, and amps. The current is the amps, the force is the volts, and the resistance is that last piece we haven't talked about yet, or at least very much. And what that means is in a circuit, it's like what the electricity is powering. So my immediate example here is a lamp. The amps and the volts are coming out of the wall through the plug. The circuit comes through, and the resistance is the light bulb, right? That's what the electricity is powering. And so that's put into this equation. Why we need to know it? Later down the road, whenever we're putting together our circuits and planning those kinds of things out, we'll use this theory some to fill in the missing holes. So again, if we know the amps and the voltage, we can figure out what that resistance needs to be, or vice versa. If we know what the resistance is, we can figure out amps and volts and from there. So that's kind of the big picture. How it breaks down, this formula uses a little bit different letters than that West Virginia formula, and here's what they are. So for Ohm's law, E represents volts, I represents amps, and then R naturally represents resistance. So a little bit different, but that's the three: E, I, and R. Now the way you set it up, much like the last formula in the last video, we can, using some simple algebra, move the formula around and figure out which missing piece we need. But just to learn it, we'll say simple with the multiplication side. So with that, the multiplication version of Ohm's law is going to be E equals I times R. So that's volts times amps, or I'm sorry, that's volts equals amps times resistance. And that's where we'll start at. So remember that one. So E equals I times R, and that's where you're going to start from. Now, the next thing to learn is how to use it and change those formulas up. We're going to do what we call the Ohm's triangle. Hopefully I can put that up somehow so I don't have to write it. I think you all can see those better. And what that is it helps you break down that formula. So you have E on top of the triangle, and then the bottom two sides you have I, and then you have R. So again, if you need to find E, what you will do, put your hand over E. Now you know that you need to do I times R. So that's the amps times resistance. If you need to find the resistance, now you have E divided by I, so volts divided by amps. And lastly, if you want to know the amps using Ohm's law, you do E divided by R. Pretty self-explanatory. We'll practice that some later down in the electricity unit. To recap, Ohm's law is the relationship between electric current, force, and resistance. When we use it is when we're trying to figure out those missing pieces in the circuit, knowing how much volts or amps we can have with the resistance, things like that. The letters are different. E is volts, I is amps, R is resistance. And then lastly, the baseline formula that we want to use is E equals I times R. Again, we can manipulate that and figure out the missing pieces, but that's where we're going to start. E equals I times R. That's Ohm's law. That's the last video, hopefully, in this series, and there'll be some more later. Deuces.